everyone, and welcome to another session at the Reactor. My name is Rav, and I'm the Program Manager at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful and mindful of other people's views, understanding of differences, and please be kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, this session will be recorded and will be available to view on Microsoft Reactor's YouTube channel. Today's session is all about Swiss Life's open source tools that can help you boost your development productivity, and it will be led by Jose, Pascal, and Philip. With that, I'm now going to add Jose to the screen, who will then introduce the session.
Thank you, Rap. Hello, everybody, and welcome to our Swiss Life Open Source Driving Innovation session. A look at our open source toolset and culture. So if you can put my slides. Can you share my screen, Rap? Thank you. So in this session, we're going to show you what we do in terms of open source and in terms of developer community. We will go through who we are, what do we do, our open source, some of them at least, and then we'll have some time for questions. But meanwhile, feel free to ask questions on the comments. So who are we first? I'm Jose Luis Latorre. I'm a developer, community lead, and architect working on Philip's team. I also am passionate about technical communities, .NET, Zurich user group. I'm leading that as well, apart from work. I'm also love public speaking and blogging, and we are having a great time here, and we will show you a bit what do we do at Swiss Life.
Yeah, hello everyone. I'm Pascal. I'm also working at Swiss Life in Philip's team. I'm also a Hot Chocolate core contributor, and I'm very invested into the open source space in .NET, and I try to establish as much as possible a graphical community in .NET.
Yeah, hello, my name is Philip. I'm also a software developer here at Swiss Life, working mostly on .NET, Azure Cloud Space. Some years ago, we started the Swiss Life OSS initiative here. Yes, so can you please switch to my slides, to my screen? Thank you. Good. So Swiss Life is a life insurance company located here in Zurich. So yes, we say we do mostly life insurance, occupational provisions, and real estate here. And to do that, of course, we need software. And what we do here in our organization, where Jose, Pascal, and I am working, is customer-facing, things like the customer portals, things like that. So we built that all in using Azure, .NET, and React. We also established a dev community inside the company for this, where Jose will tell you a bit more later. And as I said, it was like in 2019, whereby there was this Microsoft pop-up house in Zurich, where we met together to start these open source initiatives. These guys here on the picture are still all part of the team, but good thing is that many more joined in the meantime. We started with different projects, so some were already developed internally here and used for years, and then we started to open source it. The first was a Snapshooter, then we followed with Squadron, Magnet, Boost, Mongo extensions, IDOps, which is kind of a tool to manage identity server resources in a, say, enterprise way, and last ConfiX, which is still in progress. Today we will focus on on Snapshooter, Squadron, and ConfiX. Over to you, Jose, to talk about a bit more about the community.
Thanks, Philip. All right. So developer community, you can see that's our logo. It's the same colors of Swiss Life. And that was driven together of the initiative by Benjamin Hedrick and Philip, who was already one of the creators or the lead creator of our open source. My role there is leading the dev community with integrity and exclusivity, with fairness, of course, and as well to get everybody excited and motivated. So that's quite a challenge sometimes. Philip can say that, and create a sense of belonging as well and sharing. The main goal is that everybody feels at ease, at home, not judged at all, and they can openly explore the topics they love regarding technology, either they are internal or external, so to establish a learning culture as well. And of course, recognizing success. That's really important. But to be clear, I do not do this alone, not at all. The main goal is to involve everybody. So all team leads, as Philip, and the department lead, Benjamin Hendrick on F2C, that introduce this initiative are involved and in the loop, and everybody has a word. And wisdom of the crowd principle is applied extensively. And that is what creates our developer community. Then on the developer community, we are in deep collaboration with the innovation committee. As great part of today comes from technological advances. So it's good that we are in the same loop, right? So we are doing what we call the dev session, which is every 2 weeks internal session, same day, same hour. So everybody is welcome to share whatever they want and make sense regarding technology, either it's internal to share it with the other teams and even other departments. So this is a community that is reaching out to all the IT and software engineering departments of Swiss Life. Then we are organizing together with the innovation team what we call the internal hackathon, where we get together with other departments as well as some people who are not technical, so to get together and speak and create things that make sense for our company. We have as well the Innovation Day, which is the push that it was decided to invest like half a day every week, and together we put them together and we do 1 day every 2 weeks, and we call this Innovation Day, where everybody in the company can either study, they can either work in a project approved by their team lead or work in what we love the most, open source. As well, we are supporting public speaking, attending to conferences, not only to attend, but to speak as well. As we are talking now, we have 2 colleagues of us, which we are pretty proud of, Michael Stipe and also Martin. And they are, I think it was finished yesterday, the one workshop where we are showing the way we do things together with GraphQL and as well React. It's pretty cool. It's happening at NDC conferences. Yesterday ended the one at Porto, but I think there are 2 or 3 more. So if you are going to attend an NDC, please check it out. It's really worth, and we have already got a lot of very good positive feedback. Apart from that, we also have some cool swag. There we have t-shirts for the hackathon, some stickers, some logos. So we are trying to brand and get the presence together with a sense of belonging. So we are trying to do that in a pretty, I would like to say, professional way internally. Apart from that, let's not forget the core of it, which is Swiss Life open source. And from here, I like to give the word to Philip.
Thank you, Jose. Can you switch to my screen again, please? Thanks. So first, we will quickly show what Squadron is. So simply say it's a tool to help, to do integration testing. So it's a integration testing framework for either Docker containers, but also Azure resources. It's a set of NuGet packages, 21 at the moment, if you look at nuget.org, which you can use to write your tests. So we're going into a quick demo of what problem we try to solve. with Squadron is the thing like we have now a very, say, common use case. You have a database, you have some method on a repository, something which say add, and then you have a thing here which say insert one async, and you need to cover this by a unit test or integration test. So first thing was, okay, the event bus, maybe we'll just mock it out. So we create a mock of it. This one is just the native MongoDB driver thing. So there's not will be a lot of work to mock it. And even if we mock it, maybe we don't test actually the thing, what's really happening. So the easiest, what we found out is just to use a real database. But of course, we don't want to install databases on our CI/CD servers and so on. And this is where you can use Squadron. So I have here this test I want to write to test the add user, the add async method. What I need to do first is just add the Squadron Mongo package from NuGet, and then I have this already, but usually I just inject here a Mongo resource, and as I remove this here before, I need a class picture of a Mongo resource. This is just a XUnit specific stuff to say that in this initialize I want to inject this kind of resource. And now I can just say var database equals. So the Mongo resource is actually here my MongoDB container where I can do things. So for example, create a new database with a random name, and then we just say, okay, I create a store instance to test with the real database. I just use a simple mock of the event bus. I create a new user, then add this user to the database, and in the assert, what I want to do is to just query the user collection with that ID I inserted here and look if the user is here. So I can just run. And if everything goes good, it should get green. So what it's doing now actually is really spinning
Hi, Philip. I think you're on mute. You're
Okay.
on mute. Yeah, sorry. So
It's
I
better
think
now?
you might have to repeat what you said, like a few minutes.
Few minutes.
Just 2 minutes. I think 2 minutes you were on mute.
Okay, I didn't.
Yeah.
So you know where? Maybe I can just.
I think you were. Yeah. I suppose you might have to just repeat what you did just for a few seconds. Yeah.
Yeah. So I will just do it again where I add a breakpoint here. So I will add a breakpoint here and run the test again, so that we see what is happening. So it's start a container. If we look, well, now I stopped here, so there's a new one. So when I have the breakpoint here, okay, so I see now the new container pops up. I see it's running on a specific port because the ports are dynamic. So I just have to create quickly a connection of it with that 55097. So now I connect to it. So I see this randomly generated database. I see the user which has been created here in the MongoDB. So if I check this, then it's not now, and it works. And when the test is over, the container is deleted. So that is the case where we can use a Docker container. Now, there are things which are hard to mock using a container or things, and these are like, for example, an Azure Service Bus, an Azure Event Hub, a Key Vault, some features of blob storage, and so on. And for that, we have another Squadron resources, which actually really does some Azure cloud stuff. So as you saw before in the user store here, I have a method send event async. This is using an event bus, and the event bus is using the service bus client, which comes from Azure Service Bus. So to write a test against this one, I can do the very similar thing. Just I need to install the Squadron Azure Cloud Service, and then I do the same. I do the same here, where I define the cloud resource that it should create a new namespace and so on, and then run it. So I would just now execute this test. I will go into here. This is the resource group where it's created. So you see it's empty. And now he should go to Azure, create a service bus with these configurations here. So he will create a service bus with a random name. He will add a topic called foo, and he will add a queue called store. So maybe it's already here. Yeah, sometimes it takes some seconds to create a namespace, which is normal. That's why we have also the option to say do not create a new namespace all the time, but just use an existing one and maybe add some topics to it so that we don't have to wait for it. So I go back here. So now you see the service bus resource is here. So now he creates a topic, he waits for the service bus to be ready, and as soon as it is ready, I should hit the breakpoint here, so he can grab the connection string out of the Azure resource. So here we are. So you see we have a connection string of this randomly generated bus. We can run our tests, send an event. If I would go here, of course, I could see that the event is here, but I just wrote a little assertion here to read out the event of it, and it should look the same. So it's foo, test is green, and on the tear down of the test, he will start to delete the service bus again. Of course, this is not something you run in a unit test, but for integration testing, it can be really useful because there's, from my knowledge, no other way to mock these kind of resources. So I'm not stopping it, but going back to the slides. Quick overview of what we have. So this example was with MongoDB, but there's much more. There's SQL Server, Elastic, also some event-based things like Redis and RabbitMQ, and Amazon FTP servers. Some interesting things are also the generic, because generic means you can spin up any container, for example, an identity server, or even something you have in your own registry. Or compose is you can start multiple containers together. So this is useful for some more heavy integration testing. I saw some examples where they spin up some Selenium grid cluster to run the tests then this way. And as I said, there's Azure for storage, Service Bus, Event Hub, and also Key Vault in place. Now, what is the outlook of Squadron? So it's only for X unit. We plan to add N unit at the moment, even if it's quite hard. We will have to do some breaking changes, but hopefully we can do that. And we want to have a better integration for some infrastructure as code frameworks to spin up cloud resources like things like Pulumi or Terraform. Then want to have a Thai integration. So if you know Thai to use Thai for development, you could also use Thai to define your test environment and then start like the Thai start to do it in the test. And of course, as always, improve docs and samples and hopefully ship 1.0. Even we have to say, I mean, it's running for years and we run thousands and thousands of tests every day with this framework, and it's very stable. So, okay, so back to you, Jose.
Hey, thanks, Philip. All right, so let's take a look at the Snapshooter in 1 minute or less, at least the overview, I promise. So Snapshooter has this cool logo that resembles like a pointing, but in a sense is a very simple snapshot testing tool. By a snapshot, we understand that we take like a picture and we make a photo of whatever. In this case, what we usually think is of a data structure that can be simple or can be complex and with nested properties and objects. So we always had this problem that we had to test a very complex setup and then we needed a lot of asserts. This will enable us to do that in a very easy way and with only one single sentence, one single assert, which I believe is quite nice and also best practice for testing. It is simple. It is inspired by Jest snapshot testing. So the great inspiration comes from that and is meant to reduce your code and asserts. And this was developed mostly by Norman Schreiber, a colleague of mine, and of Philip, and I believe with some parts of Philip and other team members as well. So it has a lot of love here. What can we do with it? We can, well, we have a lot of flexibility. We can auto-generate the snapshots. They will be automatically generated. We don't need to create them by default. So that's a big win. So we just click and they simply appear. We can match the result to the snapshot. The syntax is very fluent, very readable. So it's meant and designed to be simple, to be have a very fluent syntax. And it has some easy magic to do some filtering and omitting. And now I'll show you with how do we do it. It's big enough, yes. So the first thing this is a very simple test project that I added from a NuGet package Snapshooter XUnit. Nothing more, nothing less. I have a very simple, in this case, customer that I have a GUID at a time, and yeah, and some other string and in parameters. And yeah, a very complex thing that will return us a key customer of us, which is called John Doe, with some other elements, and some are created like randomly, like creation date, UTC now. That's about it. And then we have a test. This is what we would have as a custom test normally. So we get the customer in the act, and on the assert, we assert several conditions together. So this is usually the biggest problem. We have to write this up and we have to maintain these. And what Snapshooter allows us is that we can get rid of it and we can do just customer point match snapshot. The syntax is very simple. Match snapshot. You can see in the project here at the right side where my cursor is, there is nothing. And if we do a build, and hopefully that runs really quick and we can execute it. Yeah, call it about Visual Studio. We can also do snapshot point match and then the customer, but I really like this syntax. It is really fluent. It is really easy to read. And then we can execute this, and we will see that two things are happening. One is a folder called Snapshooter is created, and inside of it, we have our first snapshot, which is basically a JSON representation of the object. Nothing more, nothing less, very simple. So we don't have to create it by default. We don't have to validate it. It's already created, and it's given like the proper one. But what happens when we repeat the test? It will fail. So give some love to Visual Studio. It's running. Yes, it fails. And if we look at the details, yeah, you can see, yeah, expected is different from the actual. So what was created, which is in a separate folder mismatch, and here we can do a comparison of the files, which with the proper one, and we can see clearly on Visual Studio what are the problems. Creation date differs and the ID differs. So here we have also some love from Snapshooter. What can we do? We can increase that and use some omit here. I could, let me put enter. Yep, okay, that's not that nice formatting. Sorry about that. And we can match the customer and add an object which is match options that are ignoring the field ID, creation date, and then maybe monthly income, why not? And if we do that right now, and we could delete the mismatch and the folder after having checked that with our file comparison tool, and we could run it again, and now it should be green. And if the gods of the test don't fail us, it will be, come on, green. So now you know how to use Snapshooter, how to install it. It's simply a basic NuGet package, and how to ignore a field. Nothing more, nothing less. It solves quite a few problems. It makes it easier. It becomes a lot of code that can be 5 or 8 or even quite a lot. If you have a lot of nested classes, then you may have to check a lot of things. And with Snapshooter, that becomes quite easier, a lot more simple. At the moment in the roadmap, we have include and exclude to include concrete parts of the JSON or object tree model and exclude to do the same. And then we have something that is called accepted. I know that my colleague Norman is working on it that will enable, basically it's kind of a I ignore an omit that we saw before, but that will be reflected on the JSON. So if we have a git, the git on the snapshot will be the same for both. So that's pretty nice. We can also check only for the type as well of some concrete data, but these two are really, really nice to come. Apart from that, I would say there's some reference links. We will show more at the end. So we have Swiss Life -OSS github.io/snapshooter, and the same for Swiss Life -OSS, but you can find everything at that part. And then I like to give the word to Pascal. Oh, sorry.
Great. Hope you guys have a good time. I will not really show much code today, but I will show other cool stuff. So as the last topic for today, we would like to show to you our new open source configuration system called ConfiX. I will start by showing you a simple problem, like telling how an application finds its database can become really tricky. So every application needs some sort of runtime configuration to define its behavior. Most applications need to know how to contact a database, where to find the cloud services, or how to do authentication. There are a couple of ways to do configuration in .NET. Possibly the easiest way to do configuration is with an app settings JSON file. With an app settings JSON file, you can define runtime parameters in a simple JSON file and have all configuration compressed into a single file. Once your configuration starts to grow, you want to organize your configuration you want to organize your configuration file in a more reasonable structure. And as it is just JSON, you can make a JSON object per node, and it's all nice and organized. The problem is a bit, in a modern world, you do not have one application, you probably have more than one application. You can easily share code between these different applications in a common library and use the configuration provider to access the configuration. This way, you, for example, only have to define once how you connect to a database or how you do connect to your identity server. But you end up with a lot of different configuration files in a lot of different places. And if you want to share code, all of these configuration files have to have the same structure, and the structure has to be in sync. To make matters even worse, you probably also have different environments, like, for example, QA or production. For each of these environments, your configuration is different. You have, for example, different databases, you have different identity clients. And the biggest question in the end is, how do you manage these JSON files and how do you store these JSON files in a secure way? You could just store them on the disk, but as soon as you have secrets in the configuration, you can no longer store them on the disk. I mean, you could, but you shouldn't. You also have different environments, so your configuration file is different depending on where it runs. And also, what about permissions? Not all of your developers should have access to all the secrets of the company. There are already solutions to these problems, like, for example, Azure App Configuration, where you can configure your application with environment variables. But there you lose the simplicity of a JSON file and the composability of configuration across different services in your organization. And this is where ConfiX comes in. ConfiX lets you keep the simplicity and composability of a simple app settings JSON file, but scales in a microservice world with different environments. There are 4 parts of a configuration. The first part is the application. The application consumes the configurations. This configuration follows a strict schema. An application can have many application parts. Each application part represents a running process. So, for example, a worker or an API. These parts are composed out of components. So the API has access to the database, it has access to a message bus, and has access to the identity. Each of these components can then access variables, and these variables have different values in different environments. And now I will show you how you can easily do this with ConfiX. Just need to find my mouse. There we go. So this is ConfiX. And let's first have a look at this instance of ConfiX. So we have configured 3 environments, dev, QA, and production. And we have configured a few components. So we have configured a component database, a component message bus, and a component identity. If we have a look at the component database, we see, or let's take message bus, because it's a bit more interesting. We see on the right, we have a schema defined, and on the left, we have the default values for this component. We use GraphQL for defining a schema just because it's a lot simpler to define a schema with GraphQL than, for example, with JSON schema or something. And the default configuration is the configuration that is per default applied to an application part when you add the component to the application part. And we also have a few variables that are pre-configured. And what we'll do now is we will add a new application. So this application is called notification up. Is it typed right? Yeah, looks like. And this application will have 2 parts. It has an API and it also has a worker. Once we have created the application, we can now add parts to the application. So we can say our API needs to have access to the database and to the identity server. but it doesn't. And the worker needs to have access to the message bus and the database, but it doesn't need to do authentication because it doesn't interact directly with the user. Once we have assigned components to the application part, we can configure the application part. So we can click on the application part and now change the configuration of this specific part. So for example, we're now in the application notification hub in the application part worker, and we now configure the message bus. So let's add the queue name of the message bus and add a connection string for the message bus. Now we can save it. We have now configured the component of this application part. The problem that we have is that we have different environments. So we want to have a different connection string for each environment. And we also do not really want to have the connection string just readable in the configuration file. So what we do is we go to variables and we select a variable. The variable is called message bus connection string. You can give any name you want. And we can now configure this variable in, for example, an application or in an application part. We can now set values for all the different environments and then just save the values. And once we have defined the variables for this application part, the variable is available in the application part. So we can go to the notification hub, to the worker, and when we now remove this and add the connection string, then we see that we have access to this variable here, and this variable will now be different depending on which environment you deploy the application. Cool. So we have done the configuration. Now what we have to do is we have to publish the application. So what does this mean? We can go to the application part and we can press this publish button. And if I go quickly back to the presentation to show you what I mean by publishing, this process works like this. Once a configuration is published, it is sent to the vault, which is a separate service, for safe storage. The vault returns a specific access token for this version of this of the configuration of this application part, and with this token, the application can then on startup fetch this specific configuration from the vault. In a Kubernetes environment, the vault would not be exposed to the public, so your configurations are safely encrypted in the perimeter inside of Kubernetes and are not accessible from the outside. Your services communicate directly with the vault, and this is just another layer of security. So let's do this. Let's publish the application. So let's go back. We now have published the application and not really much has happened. And this is because now the build pipeline, the CI pipeline on Azure, has to deploy the service. Because I didn't set up Azure, we just do it with the console now. When we deploy a version into a specific environment, we have to activate the version in this environment. So what we do is we claim a version. So we get the latest published version, and then we assign this version to a specific Git commit. So we take the Git. So let's have a look how this is done. We have this tooling called ConfiX, and then we can do a claim. And we want to claim the application notification hub, and we want to use, we want to claim the part worker in the environment def with this tag. And this tag is just the SHA value of the Git commit on this instance. Once we do this, we see that we successfully claimed the version and we got back a token. And this is a token that we then can use to exchange the value, the configuration value, to exchange the token to the configuration value in the end. And we can, obviously, when we go further in the deployment step, we do the same thing on QA, and we will do the same thing on production. And you see we always get different configuration values back, different tokens back. So you cannot get a configuration that you're not allowed to have access to. The whole process is also tracked in config. So you see which commit is deployed to which environment. You also see which version of the configuration is deployed. You see who has published it, when was it published, what commits are using this configuration, and you also have a full change log where you can see the difference between the changes that you made. So let's go back to the presentation quickly and see how we use this in code. So what we do in code is basically we just add on the configuration provider, we just use the extension method add wall configuration, and we specify the application name, and we also specify the name of the application part of this application. The token to get the configuration is injected as an environment variable into the container or the process, however you want to do it. And then on startup, this service will fetch the configuration from the vault. You can then use the configuration in your common library. So iConfiguration, the interface, you can write common libraries, for example, to handle connection to the identity server or to handle a message bus. We also use it for iDistributed cache and all kinds of stuff. And you just write your extension on top of iConfiguration, and then you can use in the whole company organization, you can use these extension methods with the configuration. So where do we want to go with this? What we want to do is we want to also create resources in configs. So when I create a service or an application, I also want to specify what resources I need. So I do not want to go to the Azure portal to provision a message bus, a service bus. I just want to say in the configuration, hey, I need a service bus. And the config knows that if you need a service bus, I have to provision one. We also want to have integrations for example, doing the identity server or IDOps or whatnot to provision directly identity clients, databases, and basically every Terraform resource that are available. These resources then provide variables, and you can use these variables in the scope of the application. And once you publish the application and the application is deployed, or the application part is deployed to a environment, we then create these resources in scope of the environment. So you just say, I want the message bus or service bus, or I want an identity client. And once you publish it to this environment, we create it and inject the variables. We also want to do live configuration so that you can specify certain parts of your configuration, for example, the log level. And you can basically specify that the log level should be live. And every time the developer changes the log level, it's synced to the vault, and the vault notifies the address service that the configuration has changed, and it updates the in-memory representation of this configuration. We would also like to introduce third-party services that can communicate with configs. So you can use your zero trust provider of choice and inject your database credentials, for example, directly into configs. And configs make sure that they are passed to the service and the service is updated in the end. And I think this was it for now. We have a slide that shows a bunch of links where you can find us and you can find more information. And if you guys have any questions, then we are happy to answer them.
I'm going to bring Pascal and Philippe back on the screen.
Perfect. Thank you, Rav.
So I suppose we did have one question in the chats, but I suppose, Jose, you have already answered that question.
Yep. Well, at least one of them. There is another about TDD, but I would say that snapshot testing is more for regression testing, and in a way, they can be used for TDD, right? Up to a point, and once everything runs, it becomes a regression. So that would be my response. And they work. They are functional. They are really easy, and with Snapshooter, they are really good. And I agree with link.net, and I guess who is behind that account.
Yeah, so I also agree that Snapshot is probably not the best tool if you like to do TDD. But where I use Snapshooter the most is also not for unit testing, but when you do integration tests and you get a response back from a REST service or a graphical endpoint, it's really handy to just snapshot the request, because if you set up your service correctly, the data should not change, and when the data does not change, then the snapshot will also not change that often.
All right. So, any other questions? I mean, I invite the audience to try out our open source, what you saw today. I think it's really powerful. And when we are done with ConfiX, I think it's going to be really, really cool to integrate that with how .NET is doing things. We have a private implementation that we are bringing to the open source community, as Pascal explained. And honestly, I think that the work Pascal is doing is simply brilliant.
Okay, so I think that's it then. We don't have any more questions, but thank you. Oh, actually, we just have a comment now. There it is. I'll pull up on the screen.
Okay.
I don't think that's possible at the moment. I think we do one-to-one matches. I could be wrong. What you can do is you can, if you have a JSON object, so we just serialize the object into a JSON structure. So with the omits, you can omit certain parts of the JSON, but you cannot say I want to match a string and then calculate, I don't know, Levenstein distance or something
I agree,
like that.
And according to Norman, the response is not yet. We plan to, but not yet. That would be nice. So we can check the type, but not really part of it.
Okay, I suppose we can give it a few seconds if someone wants to post a comment or a question. Yeah, link.net says, thanks all of you, much appreciated.
You're welcome.
Thanks to you.
Okay, amazing. I'd say thank you very much to, when I say thank you, those questions come up. There you go. I'll put it up on the screen.
That's a good one.
That's a good question.
Yeah, but I can maybe answer this. One thing is, I mean, we're running it in Azure DevOps on hosted agents, so you can use quite a lot of them. And of course, you have some techniques with XUnit where you can do some collection fixtures and class fixture, so that you don't need to spin up a new container for every test. So you can use a fixture, just spin up, for example, one MongoDB and create random database names for every test. So this is how we go around it to do this, because we have tests where we have like hundreds of Squadron resources starting.
Yeah, and it also really depends on the image that you start. So MongoDB is pretty quick in startup. So you do not really need a collection fixture, and there are other services which just take a long time to start up, and you just execute the test quicker than the startup is. And in this case, you know that you should just use a collection fixture, and then you can basically clean the clean the database every time you run a test, because that's usually quicker.
So it depends.
It depends.
Yeah, I mean, the limits are the physics of the machine underneath, right? So if you cannot run 1,000 SQL servers on a
or Elastic. If
1
you spin up
gigabyte.
Elastic, if you spin up the Elastic image, you lose 4 gigabyte of memory instantly. So it's recommended that depending on the image you use, you just share the containers, and then it works. I mean, we have thousands of tests running with it without an issue.
Okey-dokes. Maybe we'll give it like a few seconds.
All right. Again, the best is you try it yourself. You check it, you try, and you will see it's really, really fast. So, for example, when I came into Swift, one of the things I did is I started playing around, and the containers are started in really milliseconds, sometimes in 2 digits, sometimes in 1 if your computer is really quick. So they are created and deprecated, and the resources are reused. So even if you're in your simple Docker, it runs super fast. Well, except if you raise a SQL server. No more questions. I think we are done.
Yeah. Okay, great. As again, thank you very much to all three of you for joining us for this session. And we really hope you'll come back with more sessions for other reactors. And yeah, just want to say thank you very much. And we hope to see you again soon.
A pleasure.
Thanks.
Yeah.
Next time in person.
Yes, absolutely. Yes, definitely. In person, definitely. But yeah, thank you, everyone. Thanks for joining. And we'll see you again probably tomorrow with another set of sessions.